Well, so there is a question always that why do we study chemistry? It has got a lot of application in different fields. It is not just for learning chemistry for chemistry. There are a lot of applications. You will find it. So these are the applications. Different fields we have got the application. Organic chemistry is also not just for fun. Organic chemistry is used in medical field, particularly medicine, making medicine, and that medicine is actually. So earlier days people used to use medicine, the herbs and plants and all, but nowadays it is not available and we cannot rely upon that. Okay, Ayurvedic medicine, all these things what people are selling in the market is not reliable, not true medicine, giving something and telling that it will cure, but practically not. So allopathy medicine we are mainly following nowadays. So what is allopathy medicine? Some chemicals. So that is synthesized. So organic chemistry synthesis, synthetic organic chemistry is required for the medicine preparation. So do you understand the difference between medicine and drug? Hey, stop talking. Medicine and drug, what is the difference? Drug is the bulk material that is produced in a huge quantity, that is called bulk drug. It is made by some company and it is sent to pharmaceutical industry, so they are buying it by checking the quality control, and after that they are making a specific dose. Like 500 mg of paracetamol is suitable for an adult. So 500 mg is measured and made a tablet. So that way we are getting the medicine. And drug is the bulk production. That is called drug. Okay. Drug is not that always for addiction. Not that drug. Drug means actually it is a bulk medicine. When we precisely make the tablets, capsules and specific dose applied, then we call it medicine. So there are a lot of application, you see. Not I just talked about medicine. There is biology, or this chemistry is applied in biology. Okay, chemistry is applied in biochemistry, physics. They are all related. This science, no, so you cannot totally separate them. Physics and chemistry is also sometimes inseparable. Like I can tell you one field. Crystal lattice, crystallography. Crystallography is belongs to physics or belongs to chemistry. Very difficult to say. Chemistry people also following that, and physics also. Battery, belongs to physics or chemistry, both. Because the solar cell type of battery, physics is making that. Physics people are making that, and chemistry people they are making that lead acid storage cell battery type. Okay. So some fields are merging, physics and chemistry cannot be separated. So lot of different applications are there from chemistry. So basic difference is what? Physics is the force field. Physics is mainly dealing with the force field, and chemistry dealing with these microscopic structures and structure and property interrelationship. That is the main difference, physics and chemistry. Now there are some important drugs. Paracetamol, aspirin, Taxol, just this is their structure. So how do you come to know the structure? That you will synthesize. First you have to know the structure, then only you have to synthesize. It is given in the books or internet. How? First mankind has to know, na? Then only it will come in the books or internet or anything. So these things are coming from chemistry. Chemistry people did this. Structure analyzed, structure diagram made. And after that, you are synthesizing it.
How do you make this?
These structures, particularly nowadays, there is a lot of instruments available. They are called spectroscopic instruments. Ultraviolet spectroscopy is there at the lab. I can show you. There is ultraviolet spectroscopy. There is IR spectroscopy, NMR spectroscopy. Different other things are also the X-ray diffraction and scanning electron micrography. These are all helpful. Particularly the structure analysis is mostly done by spectroscopic techniques, at least nowadays.
So in the spectroscopy machine, we can see the structure property?
No, you cannot see that. You can get lot of hints. Practically you cannot get any structure. Have you seen electron? Have you seen proton? Then how you are drawing the structures? Electron, proton, neutron, you are drawing the different diagram round and round. Ki kore banaccho? So that is actually speculation, right? Speculation based on our circumstantial evidences. You are getting lot of information, evidence, and accumulating all this evidence to give some logical explanation, and that we are accepting because we cannot see that. Practically impossible, na? Quantum domain. Who has seen? Only talking about quantum domain. Have you seen quantum? Nobody has seen quantum. But how they are doing that? Because that is the only theory can explain a lot of things that cannot be explained by classical mechanics. Okay. So these are the drug structure. So this is also application of chemistry. That different type of solvent we are using here and there. Okay, whenever into our college somewhere someone is by mistake is using permanent pen into board, after that they are taking our help. That how to remove that by with water anything cannot be removed. So there comes chemistry. Sometimes we cannot do that. Okay, so there is some ink spot into your shirt. How can you remove that? You can take the help of chemistry people. It can be done. Okay. So these solvents, spray painting, the different type of solvents we are using, cleaning of gadgets, electronic gadgets, we are using organic solvents, cleaning of lenses. Okay. Now organic chemistry syllabus is this. As we are going into organic chemistry, I told you this is the organic chemistry class. So this is the total syllabus of the organic chemistry. Nucleophilic substitution, electrophilic substitution, nucleophilic addition, elimination reaction, aromatic electrophilic substitution. These are the 5 things we will be learning. Not all, there can be others also, but only these 5 we will focus. So first of all, nucleophilic. What is nucleophile? Nucleophile means that is nucleus loving. Phile means to seek, Latin word. Phile means to seek, S-E-E-K, not S-I-C-K, S-E-E-K. So to seek nucleophile. So what is that? Species having lot of negative charge like Cn minus, Cl minus, I minus, OH minus, NH2 minus, or otherwise they can be having lone pairs like ammonia, ethylene diamine, pyridine. So having lone pair or negative charge. So they are called nucleophile. Those who are having sufficient charge, electronic charge, negative charge, not positive charge but negative charge. Whenever they have negative charge, they can donate electron pair, they are called nucleophile. And electrophile, those are electron loving species because they have lack of electron. For example, cations rather. So what are those? Like H plus, Cl plus, I plus. Hey, what is electrophile? Tell me. Stand up please. Stand up. তোমাকে বলছি হ্যাঁ stand up. Why you are talking? When I am discussing something, you are not supposed to talk in the class. Continuously talking, you too. You also. Why are you talking? You are not supposed to talk in the class. Not supposed to use mobile. This is the minimum basic knowledge, yes? Okay, sit down. Now be attentive. So I am watching everyone. Don't think I am not watching you. So what is electrophile? Electron deficient species. Plus charge like H plus, Cl plus, I plus, Br plus. Okay, all these. Not only plus, sometimes electron deficient species like SO3, that is also electron deficient. That can be acting as an electrophile. Not necessarily there should be a plus charge on that. Just like nucleophile does not mean there is always negative charge. There can be lone pair also acting as nucleophile. In case of electrophile also the same thing. There is electron deficiency. There is a vacant orbital. Not always having plus charge. SO3 as example. Okay, so these are nucleophile and electrophile. Now this nucleophile, whenever substituting another nucleophile, is called nucleophilic substitution. Substitution means what? Replacing. Replacing. One nucleophile entering the molecule and other nucleophile is going out. The one that is entering is called entering group and the one that is going out is called leaving group. Because it leaves the molecule, that's why it's called leaving group. So this simultaneously this thing is happening. One group is entering in the molecule and other group is going out of the molecule. That is called substitution reaction. So that can happen for a nucleophilic substitution, that can happen for electrophilic. One group is entering, other group is going out. One electrophile is entering, another electrophile is going out. Now NO2 plus is an electrophile. That is entering into benzene ring, replacing H plus. So H plus is also electrophile. But NO2 plus is replacing the H plus, giving you nitrobenzene. Example of electrophilic substitution. Nucleophilic substitution. Well, you are replacing Cl minus with OH minus. Very common example. Cl minus getting replaced by OH minus. That means you have a alkyl halide, alkyl chloride, and then OH minus is replacing the Cl, giving you alcohol. Okay, so this type of reaction is called nucleophilic substitution. So this thing, nucleophilic substitution and electrophilic substitution clear. Next is electrophilic addition. Addition means getting added up. Nothing is replaced. Nothing is substituted, but one group is entered. For example, HBr addition into propene. Okay, HBr addition into propene. So what do you get? CH3, CHBr, CH3. Product is CH3, CHBr, CH3. So this type of reaction is called addition. Why addition? Because just getting added up. What is getting added up? HBr. HBr is getting added up. Nothing is going out. That is called addition reaction. When HBr is getting added, what is added first? H plus. Then Br minus. That's why it is electrophilic addition. First electrophile is getting added. That's why we are naming it. As the electrophile is approaching first, it is electrophilic addition. If the nucleophile is approaching first, it will be nucleophilic addition. Depending on the original property of the molecule, electrophilic addition or nucleophilic addition will take place. That depends. So propene. Propene as example, CH3, CH, double bond, CH2. That is propene. There is a double bond. And double bond is full of electron density, right? Double bond is full of electron density. There is a pi bond. One sigma and one pi bond. So, first of all, H plus can approach, not the Br minus. Why? Because double bond means it is full of electron density. If Br minus approaches, it will be repelled. Inter-electronic repulsion. So, H plus can be added up. Why? Because electron rich, it is full of electron, and H plus is electron deficient, it can approach and accept that electron. That is the way. So, it can take the electron towards itself and make the bond. And after that, Br minus will be entering. So, that way, if it added up, so it is called electrophilic addition, Markovnikov addition, anti-Markovnikov addition. These things are all electrophilic addition. Now, nucleophilic addition. Nucleophilic addition will be wherever there is a uneven electron cloud. Even electron cloud is ethylene, propene, butene, butadiene. These are called even electron cloud. Why? Because both the side you can, if you analyze the molecule, the electron density is uniformly distributed. Isn't it uniform? CH2 double bond CH2. It's uniform electron density. Just in the middle. It is not displaced in the left side or right side. It is just in the middle. Electron density maximum is in the middle. Throughout there will be electron, but electron density will maximum in the middle. That is called uniform electron density. Sometimes you get non-uniform, one side more and the side less. Why? Because of electron negativity difference. Polarity. Like HCl. It's a polar molecule. H delta plus and Cl delta minus. That is a polar molecule. Now, if you take CH3CHO, CHO, what is the structure? C double bond O. Carbon has got double bond O and one has hydrogen. So, in this case, carbon bearing some delta plus charge and oxygen bearing delta minus charge. Difference in electronegativity. Carbon is electropositive compared to oxygen. Oxygen is more electronegative. So, oxygen bearing delta negative charge and carbon bearing delta positive charge. I'm just giving you introduction. After that, we will be showing you everyone, details. Okay. Just this is an overview I am giving. And after that, I will be going in details. Don't think that I am teaching like that. So, overall minimum idea, maybe you know a lot out of this because you have already passed 11, 12. So, these things are all 11, 12 concept, isn't it? Okay. So, when that nucleophilic addition will take place? Whenever there is an uneven electron density. But maybe you have not used this type of terms, even electron density, uneven electron density. These you have not used. You have seen this is polar or non-polar. You have heard the term. There is a that C double bond C. Whenever there is a C double bond C or a C double bond O, there is a difference. Okay. When C double bond C, there is electrophilic addition. Wherever C double bond O, nucleophilic addition. Okay. But it's better in this way to describe this way. Even electron density and uneven electron density. Even electron density means uniform electron density and uneven means non-uniform. Non-uniform happens whenever like C double bond O. There is a non-uniform because carbon bearing delta plus charge and oxygen delta minus charge. So electron density will be, the cloud will be more over oxygen. So uneven. So in this case, what will happen? The nucleophile will be added. Nucleophile will be added and it's called nucleophilic addition. Next is elimination. Elimination means something goes out. Nothing is getting added, just something going out. For example, you have alcohol, CH3, CH2OH, ethyl alcohol. If you give concentrated H2SO4 and apply 170 degrees centigrade or so, there will be double bond formation. Okay, double bond formation, that is elimination. What is getting eliminated?
OH.
H2O. Whenever something goes out, just think, whenever something goes out, it must be stable. It should be stable, otherwise it will not go out. Replacing possible, but whenever going out itself, it will be a complete entity, like water. Like water, cannot be OH minus. Okay, because OH minus has got no stability. So whenever goes out, it will be a complete entity, like ammonia goes out, H2O goes out, alcohol goes out. It can happen. Achha. Because stability, nothing else. So aromatic electrophilic substitution already I discussed that H plus getting replaced by NO2 plus. That was the example. Now going to step by step deduction, I can say. Step by step deduction. This one is what? CH3, CH3, CH3. This way you can write. This this chain that we are drawing, this line, and line, these are all CH3, 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 CH3. And they are Br here. So what is this called? Tertiary butyl bromide. This is tertiary butyl bromide. Carbon bearing 3 methyl groups and 1 bromine. Tertiary butyl bromide. Okay. Now we are just exposing it to the reaction. So Br minus goes out first. Because why? Why? Because this one is sp2 hybridized and this one is sp3 hybridized. This is sp3 hybridized. For carbon bearing 4 bonds. So sp3 hybridized. Carbon bearing 3 bonds, sp2 hybridized. So here plus charge is developed by leaving the bromine and it is going out, so temporarily going out. It will not final product. Don't get misconception from my last word. I told something stable should go out, but it is actually in between happening. It is not complete. So it can happen. Just it is going out, but it will accept something else to make a complete product. So here the bromine goes out, Br minus as a Br minus, and it got a positive charge. Why it is happening? Because it has got certain stability. This particular species has got certain stability. Why? Because this CH3, CH3, and CH3, they are having plus I effect, inductive effect, giving the stability. CH3, CH3, CH3 giving the stability, that is called inductive effect. Carbon bearing 3 different methyl groups, and that's why this tertiary butyl carbon can give carbocation. This is called carbocation. It has got certain stability because this methyl, and this methyl, they are giving plus I effect, inductive effect. What is inductive effect? That is giving plus I effect is giving stability to carbocation, and minus I effect is giving stability to carbanion. So this is carbocation generated, but this is not a final product. This is called intermediate. Intermediate. And when the process is going on, the bond is being broken but not yet broken. That pathway, it is called transition state. Transition state means the bond is being broken but not yet broken. When the bond is broken, what you get is called intermediate. What is the difference? Transition state has the energy peak at the top of the barrier. But whenever it is at a got certain stability, then it is called intermediate. And intermediate will occur whenever there are at least 2-step process. If it is a 1-step process, there will be no intermediate. Because you have got a reactant here, you have got product here. There is no, in between there is no step. So there cannot be intermediate. But if there are at least 2 steps available, you are getting intermediate. So here, what you get? Carbocation. That is an intermediate. Carbocation intermediate. Very popular, common. You will find the term here and there. Carbocation intermediate. Quite stable. Now, Cl minus is taking the place here. So getting Cl. Okay, so Br is replaced by Cl. Here, it is obviously the solution has HCl, so that Cl entering here and Br goes out as HBr. But just can you tell me, is this reaction feasible or not? This reaction is possible or not? Feasible or not? I am not say possible, feasible. Whether the reaction is feasible or not. What is your thinking? What do you think? This reaction will occur or will not occur? Can it replace this way? Br is getting replaced by Cl? It will not happen.
আচ্ছা স্যার
I'll tell you. Though example there, yes.
উল্টোটা করে
উল্টোটা হবে। That was going to tell. Actually, the opposite will happen.
ইলেকট্রোনেগেটিভিটিটা বেশি
না তার জন্য হবে না, তার জন্য নয়, সাইজ ইজ দ্য ফ্যাক্টর। Br minus is a larger size, it can deform itself and from a distance it can replace the Cl, which is less deformable. Br is more deformable, so it will, from the longer distance it can start making the bond, and whenever Br is making the bond, that is releasing certain energy, that energy is breaking the Cl bond. Carbon Cl bond, carbon chlorine bond, it will be broken and it will need some energy. That energy is supplied by the Cbr bond. That's why from a longer distance Cbr bond is getting started and CCl bond will be breaking, and that can simultaneously occur. So Br will replace the Cl, not the opposite, because bromine is larger size, so it is a better entering group as well as better leaving group, and this reaction is called Finkelstein reaction. Okay, this reaction is called Finkelstein reaction, name reaction.
So here we can't consider the steric hindrance.
Okay, steric hindrance, if you consider also what is the
Size of Br
no,
is
actually
so large
it
that
is
it
happening, no, but it is happening in two steps. First of all, carbocation is formed, and that's why steric crowding will not occur, because it is a planar molecule and bond angle is becoming 120 degree, quite away, distance is more. That's why this reaction can occur, but opposite will occur rather, because Cl will be replaced by bromine easily, but Br will be replaced by chlorine. It's not impossible, maybe 10% happening, because it is always in equilibrium, no, equilibrium. Some amount may happen. If you take suppose this bromide and give some high concentrated Cl minus, then some amount may proceed, because backward and forward reaction always goes on. Okay, I'll give you one example. Normally we think the reaction that is more stable, that will occur. Acha. Now Na2 in the legumes, legume জানো, লেগুন হচ্ছে হাই কনসেন্ট্রেটেড সল্ট ডেড সি লাইক ঠিক ডেড সি শুনেছো? ডেড সিটা কি? প্রচুর সল্ট কন্টেন্ট, এত সল্ট কন্টেন্ট সেখানে কোনো মাছ বাঁচতে পারে না, তাকে বলে ডেড সি। এটা কেন হয়? Because getting dried up, continuously evaporation going on, and that concentration of salt is increasing, rising so up that practically no aquatic animal can survive with that. বাঁচতে পারে না, সেই জন্য একটা ডেড সি বলা হয়, কেন কোনো লিভিং বিং থাকে না ওর মধ্যে। অ্যান্ড দ্য ওয়াটার ইজ সো হেভি দ্যাট ইউ ক্যান ইজিলি ফ্লোট দেয়ার, তুমি ভেসে থাকবে, তোমাকে সাঁতার কাটতে হবে না। সো ইট ইজ লাইক দ্যাট, হ্যাঁ, বিকজ অফ দ্য ডেন্সিটি, ভেরি হাই সল্ট কন্টেন্ট, that is called legume. That type of thing is called legume, dead sea. So, but I was talking about this salt content, NaCl content is very high, and in the bank of the ocean, that Dead Sea, there is a lot of calcium carbonate, because calcium carbonate is a natural ingredient of soil. Calcium carbonate is there everywhere in soil if you analyze. So calcium carbonate and NaCl coming in contact, nothing should happen. In the laboratory, if you do, nothing will happen practically. Okay, no reaction will take place. If you take calcium carbonate and add some sodium chloride, nothing will happen, because both are quite stable, no reaction. But it is found that lot of sodium carbonate dump at the bank of the lagoon. How did it happen? Tell me. কি করে হতে পারে? Sodium carbonate dump, trona it is called, TRONA. Sodium carbonate dump, natural sodium carbonate dump is called trona. Dump, জমা হচ্ছে সোডিয়াম কার্বনেট ডাম্প। ওকে, ডাম্পিং সোডিয়াম কার্বনেট, ডাম্পিং মানে হিউজ হিপস, ওকে, স্তূপ। সো দ্যাট ইজ গেটিং অ্যাকুমুলেটেড অ্যাট দ্য ব্যাঙ্ক অফ দ্য লেগুন, সোডিয়াম কার্বনেট। বাট হোয়াট ইজ দ্য সোর্স? কী করে হতে পারে, কোত্থেকে এলো? ওভার এ লং পিরিয়ড অফ টাইম সোডিয়াম কার্বনেট রিয়াক্টেড ক্যালসিয়াম কার্বনেট লিটল বিট, প্রডিউসিং দিস টোনা। Okay, so this is actually back reaction which is not supposed to happen. উল্টোটা হতে পারে, কিন্তু এখানে এটা হচ্ছে ক্যালসিয়াম ক্লোরাইড প্লাস সোডিয়াম কার্বনেট তৈরি হয়ে গেছে, বাট হোয়াটস সাপোজ টু হ্যাপেন ইজ জাস্ট অপোজিট। কি করে? ওভার এ লং পিরিয়ড অফ টাইম, ইফ ইজ এ লং এক্সপোজার গিভেন, ইট উইল গো ইন দ্য ব্যাক সাইড, বিকজ equilibrium will be established. একটা reaction, whenever you are studying a reaction, there is some forward reaction, some backward reaction. So in this case, backward happened. Because you are giving a product in a high concentration over a long period of time, so backward reaction happened, making it an equilibrium. So you are getting, and this sodium carbonate is going away from the ocean, so it is not coming in contact again. আস্তে আস্তে জম হচ্ছে, জলের ধাক্কায় ধাক্কায় সরে সরে গেছে, সো ডাম্প হয়ে গেছে, হিপস তৈরি হয়ে গেছে. ওকে, ইট ইজ এ ন্যাচারাল ফেনোমেনা. Practically, initially, nobody could understand how it could happen, but after that, this is the explanation given by scientists. Calcium chloride, totally not source of calcium chloride. Sodium chloride is there in the salt, as a salt in the legume. And this sodium chloride reacted with calcium carbonate over a long period of time, producing calcium chloride and Na2CO3. That NaCO3 is going away from the water because of this thrust. জলের ধাক্কা আছে না? So it is going a bit away, and that way it is dumped again and again over a long period, hundreds of years. It happened. Okay. So that proves what? Opposite can sometimes happen. SN1 reaction is this. Whenever we are following SN1, this is SN1. SN1 means, well, I need to explain again. What is SN1? Substitution nucleophilic unimolecular. That is the full form. S for substitution, N for nucleophilic, 1 for unimolecular. So substitution nucleophilic unimolecular. That way you can read. Substitution means replacing. Nucleophilic, one nucleophile replacing another. And unimolecular, because in these two steps, this is the first step is difficult step. Second step is quite easy, because once carbocation is formed, which is not very stable, it can accept another anion and forming a complete product. That is quite natural. So this one is spontaneous, but this one is difficult. So this is called rate determining step. The difficult step is called rate determining step.
The first step, sir.
Huh. So what is the meaning of rate determining step? That determines the rate of the reaction. So this is the rate determining step. So in this rate determining step, how many species there? Only one. This is not taking part. First of all, this is not taking part. This Cl- is not taking part. There is no role of Cl-. First, Br- goes out. That is the only thing. So that's why how many molecule involved? Only one. So that it is called unimolecular. So in the that means number of species involved in the rate determining step is called molecularity. So unimolecular means molecularity 1. So how do you define it? Number of species or molecule involved in the rate determining step. So this is the rate determining step. The number of species involved is only 1. That's why it is called SN1. And ultimately substitution. So that is substitution, SN1 reaction. So what is the driving force of SN1 reaction? Carbocation stability. You have to have carbocation stability. Carbocation should be stable, then only this SN1 reaction can take place. Reaction can happen in so many ways, but if it is SN1, it has to go by this way, carbocation formation, and that's why carbocation stability is a must. Right? It is inevitable. You have to have a stable carbocation. Now this carbocation stability can be by different reason. Here, what is the reason? Plus A effect. Plus A effect. Sometimes resonance can be another factor. Okay, like this carbocation. Resonance stabilized carbocation. This is a carbocation and is resonance stabilized. So there can be resonance stability. There can be inductive effect. Inductive effect, resonance. বলো।
But sir, here molecule তো এখানে স্টেবলি ছিল, তাহলে ওর কার্বোক্যাটায়ন ফর্ম করা কি দরকার ছিল?
রিঅ্যাকশনটা করলে ওর আলটিমেটলি সুবিধা হবে।
দরকার নেই,
Because
তো ব্রোমিনকে নিয়ে হ্যাপি আছি।
না, কি তুমি দেখো, যদি ভবিষ্যৎ তোমার আরো উজ্জ্বল হওয়ার সম্ভাবনা দেখা দেয়, তুমি অনেক সময় রিস্ক একটু নিতেই পারো। সেটা কি করে? ইট ইজ গেটিং কম্পেনসেটেড আলটিমেটলি। Molecule does not understand all this, but molecule understand one thing, that is ultimate, that energy release or absorb. Ultimately there will be some energy release. This product is supposed to be more stable compared to this product, then it can happen. If it has to cross the barrier, but ultimate product should be more stable compared to the initial reactant.
Why it is most
This no, in this case I'm not telling this more stable. Actually this Br- I already told, na, Br will replace Cl, not the opposite. Okay, so but whenever the product stability is more, then reaction can happen, though there is a barrier. So molecule is never, just understand one thing, molecule is never very stable, always it will have a sort of vibration. Molecule কখনো স্থির থাকে না, it will always vibrate, right? So as it is vibrating, so that means some sort of instability always inherent in it. It is quite randomly moving always, not very happy state like us. Okay? So always it is vibrating, moving and all these things. So if you can enhance this vibration, it will break. Enhance, this vibration is going on like this. Now if you give some sort of photon or some heat, so molecule will be vibrating more, so it will be atomized. After that, once it is atomized or some cation is formed or anion is formed, then it will be going into some, there are two options, either it will go back or it will go ahead. Initially the atom is formed, after that it has got two options, either it will go back, that is backward reaction, or it will go ahead for something else. If the forward product is more stable, then it may go in that direction. Always it will see the profit na, for like human only.
ঠিক যদি উল্টোটা হতো তাও কিভাবে স্টেবিলিটি হতো?
ওই যে ব্যারিয়ারটা once you cross the barrier, it can reach there. I'll just explain. Suppose it is like this. So this is the energy and time. The reaction is going on. So this is reactant, this is product. So this product is less stable. Then also we are finding some product. How possible that? This is ultimately not getting benefited, but still the reaction is happening because of this type of that molecular chaosness, I can say. So if some of the molecule will at least cross the barrier, because it has crossed the barrier, could not come back. गलत जगह पे एक बार चला गया, वापस आना हमेशा पॉसिबल नहीं होता है ना. Again you have to get the energy to cross the barrier. Somehow it got the energy, crossed the barrier and got to the product side, but coming back to the reactant side again will need some energy that may not be available, so some of the molecules already transferred there, and equilibrium is a natural tendency for all the molecules, always equilibrium. So it will try to reach the equilibrium. If the product is more stable, it will go towards product side more, and if the reactant is more stable, it will try to go towards the reactant side more, but always there is a combination, both product and reactant will be there. That is our reversibility. All the reactions are reversible, and we already heard that term. All the reactions are supposed to be reversible. Okay?
So why it is
Theoretically, all reactions are reversible, isn't it?
क्लोरीन के साथ मोस्ट स्टेबल क्यों है?
कि
क्लोरीन के साथ मोस्ट स्टेबल क्यों है?
क्लोरीन के साथ मोस्ट स्टेबल क्यों है? मोस्ट स्टेबल तो नहीं है, ये तो मैंने जस्ट एग्जाम्पल दिखा है सिनेमन के. ये तो जस्ट कैसे रिएक्शन होता है वो दिखा है, इसका मतलब ये नहीं कि ये ज़्यादा स्टेबल है.
रिएक्शन ही नहीं होगा, ज़्यादा स्टेबल नहीं होगा तो.
नहीं होता है.
ये सर अभी तो
बोला ना barrier. No, देखो, there are two things. Let me clarify them. There are two things. One is called thermodynamic. Hey, listen carefully, otherwise nobody will understand. Stop talking. So there are two things. One is called thermodynamic stability. Another is called that rate of reaction, kinetic stability. One is called thermodynamic stability, another is called kinetic stability. Kinetically controlled product, thermodynamically controlled product. Let me clarify the matter. Thermodynamically controlled product and kinetically controlled product. So what happens if the product stability is more compared to reactant? That is governed by thermodynamics. Del H is negative, more del H negative, more spontaneous, etc., etc. So that is called thermodynamic stability. Okay. Another one is called kinetic stability. What is that? Kinetically controlled product. What is that? So if the barrier is smaller, it can cross the barrier easily and going for a less stable product. So at the same time, it can have another pathway. Suppose you have got another pathway. This is product 1 and this is product 2. I think now we'll understand better. Okay, this barrier is more. For product 2, the barrier is more, and for product 1, the barrier is smaller. So the molecule will go by which path? It should go towards P1 or P2, tell me. Supposed to be, na? That is called thermodynamically controlled product. But if you give sufficient time and energy to reach the equilibrium, then it will go to P2 more. But if you are not giving sufficient time and energy so that it can reach the equilibrium, suddenly you stop the reaction and you can get the P1 also. A lot of P1 product. Because the barrier was smaller, So molecule crossed the barrier and reached B1 and could not go back. Trapped there. Very simply trapped there. It can be there. It can be possible. It happens. Acha, next. SN1 reaction, I am going into a bit detail here. This is SN1, carbocation form. Now in this carbocation formed here actually. This is the carbocation. This is the tertiary butyl group maybe. So tertiary carbon I can say, not tertiary butyl. Tertiary butyl will be of hydrogen, then only. Otherwise this one I can call tertiary carbon. Now this bromine goes out, you are getting a carbocation which is sp2 hybridized, and there are two options here. Attack can be from top or attack can be from bottom. Why? Because it has become a flat one. The carbocation is flat. Now from the flat sheet it can attack from top or from attack from bottom. You may think both are same, but not always, because stereochemistry may be different. Okay, apparently looking same, but stereochemistry may be different. Product looking like same product, but actually stereochemically if we analyze, there may be some difference, because they will be mirror images of each other. The products formed will be mirror images of each other. Achha, so let's analyze that. Top face attack. Attack from top, you are getting this product. Attack from bottom, you are getting this product. Apparently looking same, but actually they are mirror images. Sometimes these mirror images can be the same, sometimes may not be. If this carbon is chiral carbon, 3 different groups are there, and here there is a 4th group has come. So 4 different groups has come. So this will be a chiral carbon. Chiral means asymmetric carbon. Now this is asymmetric carbon, so 4 different groups, and here also this. But these and these are mirror images. So they will be enantiomers. Mirror images of each other, stereoisomers, they are called enantiomers. So these and these will be formed enantiomers. And these two products you get enantiomers. Now, original configuration you see, bromine was top and these 3 were down. What is this product here? OCH3 is replacing bromine, and you are getting this product. But these 3 has got same position, you see. This and this you compare, this and this. Now here this bromine is replaced by OCH3. Otherwise these 3 groups are in the same position. This is called retention product. Retention product. Because the configuration is not changed. It was like this, it is like this only. Only OCH3 was there, Br was there, it is replaced by OCH3. That is called retention product. Otherwise it will become just opposite. Because bottom attack has happened, so this other 3 is flipped above, flipped up, ulto হয়ে গেছে, it has got flipped. So you are getting inversion product. So 50% retention product, 50% inversion product happen into SN1 reaction. These two mirror images are equal, 50-50 possibility of attack. That's why this is 50%, this is 50%. And these two together, what you get is called racemic mixture. এগুলো লিখে নাও। জানো না জানো আমি জানি না, লিখে নাও। So in SN1 reaction, we get, in case of SN1 substitution reaction, we get 50% retention and 50% inversion product. In SN1's substitution reaction, we get 50% retention product and 50% inversion product. This mixture is called racemic mixture. This mixture is called racemic mixture, which is optically inactive. This is called racemic mixture and it is optically inactive due to external compensation. এই কথাটা লিখে নাও, due to external compensation. 50% D and 50% L, D and L, dextro and levo product, 50% D product, 50% L product. One will be D product, other one will be L product. Just opposite. D and L, small d, small l. Due to external compensation. Due to external compensation. I have to clarify what is the meaning of that. External compensation meaning what? External compensation means one molecule is giving certain rotation, optical rotation. Another molecule is just mirror image. So it is also giving optical rotation, equal and opposite rotation. That means compensation. Equal and opposite rotation. That means compensation. But it is externally from another molecule. That's why it is external compensation. Do you understand or not? Two molecules, one giving rotation this direction, another giving rotation this direction, equal and opposite. So this is compensation, but it is coming externally because it is coming from another molecule. So it is external, and so it is called external compensation. So this compound is this mixture is optically inactive due to external compensation, called racemic mixture. Racemic mixture is yeast. It is mixture of 50% D, 50% L product, and it is giving equal and opposite rotation. And that's why the overall mixture is optically inactive, and it is due to external compensation. Another thing, what is D and L? As I already told you D and L, so I have to clarify what is that. D means dextrorotatory product, right hand giving right hand rotation of light.
Dextro and
Lever means giving left hand rotation, and this rotation of what? Plane polarized light. Not rotation of the molecule, rotation of the plane polarized light. If you pass through this optically active compound, there will be rotation of plane polarized light to certain direction, either clockwise or anti-clockwise. If it is giving clockwise direction, we call it dextro, and anti-clockwise is called levo. In physics, in the physics department, we are buying some polarimeter. Okay, so that instrument is called polarimeter, where you can measure the optical activity. Compound is optically active or inactive, we can measure by polarimeter. So if it is optically inactive, you find no rotation. If it is optically active, you get certain rotation. If it is right hand rotation, dextro. If it is left hand rotation, levo. So that is, in short, we are calling small d, small m. Dextro and levo, small d, small m. Okay. So this is all about SN1 reaction. One more thing, solvent stability. So if you give some polar solvent, SN1 reaction will be facilitated. It will be enhanced. Why? Because it is giving carbocation stability. Solvent is giving carbocation stability. How? How it is like this? This is R plus, some carbocation. So this is giving stability by some polar molecule like water. Got it?
Yes.
This is giving stability. So carbocation is stabilized by this type of solvation, by this solvent. And if the solvent is water, very good. It is called hydration energy. So it is released. Okay, that's all for today.